Hello everybody, I will start my today another coding session. So today I serve this question. Merge two sorted list. You were given the heads of the two sorted linked lists, list 1 and list 2. Merge the two lists into one sorted list. The list should be made by splicing together the nodes of the first two lists. The list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. What does it mean by the first two lists? What is another list? I don't know. But I think I just need to merge two given list. Okay. So in this question, so I'm given two heads of certain linked list. So head 1, which is the node, and head 2, which is also the node. And I will return the head of the two sorted linked list like this. Okay. And as a constraint, I'd like to confirm head 1 and head 2 can be null or not. And I confirm this. The number of nodes in both lists is in the range 0 to 50. Okay. So this can be null. Good. So as that being said, I think as the edge case, I think none and none. If there's a given, I should return none because there's no node. And if I'm given none and node 1 only, then I should return node 1. Yeah. The same node as given. Okay. So let me think of this question with an example. So let's say I'm given this, and I'm also given this. In this case, what I'd like to create and return is something like this. So the brute force approach should be create the node of the list. Every node in the list, head 1 or head 2, both of the list, and sort them by the value. Then, firstly, before creating the list, I remove all the connections of the list and create the list of the nodes and sort them by the value and then connect them. But it takes n log n time, assuming that there are n nodes from both lists. I mean, the total number of nodes is n. In that case, it takes n log n time. But I think the brute force duplicate the list of nodes and sort and connect to the merged linked list. So it takes n log n time, I said. Okay. But I think I can optimize this. So I use 2 pointers, pointer 1 and pointer 2. And also, sorry. Okay, so I use the 2 pointers and I have the returned, list. Let's start with the pseudo head. Let's say node num, like this. So I move 2 pointers, P1 and P2. And if P1 is smaller than P2, in terms of the value, I pick this one and connect this. I need current pointer, even in the return linked list. So I would say current.next is node 1, and that's it. And also I have to cut the p1.next and move it here. Then move P1 and current. Okay, so I mean, or maybe it can be, equal the same. I would say remove, or I should say P1 node next is none. I do this first and connect as current.next, then move P1 and P2. I will do this. So this is the basic flow. So I point this P1, node 1 to current.next and move P1 and also move current. And then, because now P2 is smaller, this 3 should come next as a current.next. So I move it here. And then move this P2. And now P2 is smaller, so, and I move current. And then node 4 should be here. Then I move P2 and also current. Here, there isn't anything pointing from P2. So I just move P1. Yep. And P1 here. Then move the P1 pointer and current pointer. So that's the thing. Okay. So I do this until P1 and P2 is none. As long as P1 is not none or P2 is not none, I do iterate this. Okay. Basically, I use 2 pointers. Okay. So that being said, let me do the complexity analysis. So for time complexity, assuming that there are n1 and n2 nodes for each of first node, first linked list and second linked list, it should be n1 plus n2 time complexity because I have to move P1 pointer n times and P2 pointer n times, or n2 times. For space complexity, I don't need any extra space. Okay. That being said, I will start implementation. So okay, then P1 is list 1, P2 is list 2, so this is used as a pointer. And also current should point to read. Okay, so now it looks like this. I do this again. And as I said, P1 or I'm, pick P1 node or P2 node. But if P1 is none, in this case, I pick P2. And if P2 is none, obviously I pick P1. Otherwise, pick smaller one. Yeah. So when P1 is none, yeah. So in this case, firstly, because now P1 is known, it works like this. In this case, pick P2. So current.next is P2. So now this is, let's say, it looks like this. In this case, current.next should be p2. So 3 should come here. Then p2.next is none. No. I have to make sure when current.next is p2. Yes. So let me say instead picked is p2. Then let me move it first. p2.next. Yeah. Then what happens is this p2 is chosen as picked, and p2 dot is equal to p2.next. So p2 is moved. So now what I can do is pick.next is none. Okay, so now picked is 3. Wait me. No, so I don't need picked. I can do picked current.next. The current.next should be p2. It should now pointing to p3. Node 3. Then p2 is p2.next. I move this. Then I should say move current. Sorry. I move p2 and I move current. And in the end, I set current.next is none. Yep, I think this is it. So current.next is p2. So now again, 3, 4 comes here. Yes. Then p2 is p2.next. So this p2 is moved. Then current.next, current is moved. And then current.next is none. No, current.next and current comes here. And this is changed to 0. None. Okay, good. Okay, here in line 75, but let me say pick p1 is false. Let me use the flag here. So pick p1 is false here. Or maybe I can do. Yeah, it's okay. Pick p1 is true here. Then tell if p1 dot bar is smaller or equal to p dot bar. In this case, pick p1 is true. Otherwise, pick p1 is false because I should pick p2. In this case, I pick p2. Yeah, so this should come here. Okay, and if I pick p1, let's say something like this. Yeah, it's okay. So the first thing I do is current.next is p1. And what happens is this one is copied to here, or I should say current is pointing this. Then I move current pointer. And then I have to move P1 fast. Maybe I can do it here. P1 is moved and current is moved. Then current.next should be none. Yep. Okay. Basically quite symmetric operation I did for P1 and P2, obviously. Then in the end, I should return read.next because read is pointing to the pseudo node. So merged linked list starts from read.next. Okay. So let me quickly dry run. First case, the edge case. P1 is none and P2 is none. In this case, read is pointing to the pseudo head and current is read. Yep. And here, P1 is none and P2 is none. So I go out of the while loop immediately and return read.next. Read.next is this one's next node, which is none. So none is returned. Okay. So expected none, and I pass this test case. Okay. Let me check one more case. P1 is say 1 and P2. Yeah, let me try this. In this case, read is firstly pointing to pseudo node. Okay, then P1. Sorry, this is L1, L2. So now P1 is pointing to here, and P2 is pointing to here. And current is pointing to here. Firstly, P1 is not known. Yes, I go to line 84, pick P1. I don't need this. So P1 is not known. P2 is not known. So I go to line 88. P1.bar is smaller than P2.bar. No. I go to line 91. Pick P1 is equal to false. So I go to line 98. So current.next is P2. So this current is pointing this. Then P2 is P2.next. Good. Next. Current is current.next. Yes, so it should be here. Then current.next is none. So this is now none. Okay. Good. So far this is as expected. So I come back to line 83. P1 is not none, P2 is not none. P1.bar is smaller than P2. So now I come to line 94. Yep. So P1 is P1.next. And current is current. Current.next is P1. So it should pointing to this. P1 is P1.next. Current is current.next. Current.next is none. Yes, it already none. Okay. Yep, so far as expected. And I come back to line 83. P2 is not none. I go to line 84 because P1 is none already. Pick P1 is equal to true. Yeah. So I come here again. Current.next is P1. No. Sorry, P1 is none. So pick P1 is equal to false. So I come here now. So current.next is P2. Okay, and it's been 20 minutes. Okay, so P2 is P2.next. So here, then current is current.next here, and current.next is none. It's okay. Yeah. Then now P1 is equal to none and P2 equal to none. So I go out of the while loop and go to line 104 and return read.next, which is 234 none. Okay. So also I passed this case. Okay, so I covered all the lines. Yes. So I'm pretty confident my code. Let me submit. Good. Okay, accepted. Great. Okay, so let me quickly wrap up. So today I solved the question, merge two sorted lists. So in this question, I'm given two linked lists, and my task is to create the interleaved merge linked list, and each of the linked lists should have the original node as the elements. Yeah. So for this question, I use the 2 pointers. Pointer 1 moving list 1, pointer 2 running on list 2. And yep, I move the 2 pointers. If P1 is smaller than P2 value, I move the P1 pointer. Otherwise, I move the P2 pointer after connecting the node into the returned linked list. Okay, that being said, I finished my today's coding practice. Thank you so much. Bye.